To understand how the measures of dispersion work and why we might care about them, I'm going to begin here with a quick example where what we are given is 2 brands of cell phone battery tested in 6 trials with the results in the table, and we want to determine which of these is the more reliable. So the first thing we can do here is try and get a sense of how these things behave overall. And to get a sense of overall behavior, usually our best bet is to think in terms of central tendency and in terms of something like an average, where the standard, as I said before, is the mean. We shouldn't always rely on the mean, but it is what we default to. So for our first case, the mean with battery 1, so I'm going to call that XB1, which is way too many subscripts, but that's what we've got here. We have those values 4, 24, 20, 12, 16, 8, and 6 total values for an average here of 14. Meanwhile, for battery 2, XB2, we have 14, 18, 12, 14, 16, and 10, all divided by 6, where if you take those numbers and you spit them in, pull them out, you get another 14, which says that based on average tendency, these are equally good batteries. But looking at those values, they're obviously not exactly the same. This is another weakness of thinking just in terms of central tendency overall, not specifically the mean, although the mean is what we have here, that they don't really take into account any sense of how spread out the data set is. This is fairly tight, that's fairly wide. You might look at this one and say, hey, I'm willing to risk 4 hours if I might get a full day, whereas over here you'd rather say, I have a pretty good chance of getting 14, I'm probably going to get 14, so maybe I prefer that one. But the point is, our measures here aren't telling us enough. We want to get a little bit more. That's where we get our measures of dispersion or variation. We're going to look at the most simple one that we have first, which is called the range.